This is number 3 from the lab portion of the summer packet. If you read the problem, the first thing that you have to do is some subtraction with the data points. So we'll get to that in a minute, but ultimately we're looking for the empirical formula. Okay, so let me just go through the general rules for finding empirical formula. Hopefully you'll recall this from first year chemistry. If you're given percentages, you just change them to grams. You can do that because you're assuming you have 100 grams of your compound. So then the percentage would directly go to grams. Then you use dimensional analysis and molar mass to go from grams to mole for each element. So if there's 3 elements in the compound, you're going to have to do 3 of these conversions. Then you're going to divide each of your answers by the smallest answer, and that'll give you the ratio, basically the mole ratio of the elements to one another. If those ratios aren't super close to whole numbers, you can't round them. For example, you can't round like a 1.75 up to a 2. Okay, it's not close enough. Instead, you'd have to multiply through to get whole numbers. So, as a reminder, if you have a 0.5, you multiply those by 2. Okay, and that'll give you a whole number. If you have a 0.25 or a 0.75, that's going to be times 4. If you have like a 0.33 or a 0.66, that's going to be times 3. And don't just multiply the one that's not the whole number. You have to multiply all of your values in order to get the whole number. This particular example, we're not going to need to do that because we kind of end step 3 with whole numbers. Now I'll show you the subtraction that you need to do in order to get the grams of your elements. So in the first data point here, you have just the mass of a crucible and the lid. In the second data point, you have the mass of the crucible, lid, and titanium. So the only new addition here is titanium. So if you subtract these 2 values, you're going to get the mass of titanium. So you would show this work, but I'm going to cheat a little bit and just write the answer. So 2.30 grams of the titanium. Then next you can look at what we're doing. We're heating this. So think about what's in air. There's nitrogen, there's oxygen, there's argon, which is not going to react with anything because it's a noble gas. And then look at part A. It says titanium oxide. Okay, so apparently it's oxygen that's reacting with your titanium from the air. So if you look at these 3 data points, they're all the same, right? It's the mass of the crucible, lid, and the titanium product. So that would be the titanium oxide. But we heated them 3 different times. So that's called heating to constant mass. If there's either no change or very little change between the last 2 masses, it means that you've accomplished kind of what you're trying to do. In this case, it was we've combined it with as much oxygen as possible. Sometimes you're like drying something out, so you'd want to lose all the water that you can, for example. But here, like up here, we did not add as much oxygen as we could have because there was a pretty significant change from first heating to second heating. But between second and third, there really was a very small change. I mean, that's within the uncertainty values of the balance. We want to find the mass of the oxygen that combined with the titanium. So in order to do that, we will take the third heating and subtract from it the mass of the crucible, lid, and titanium, because the only thing that this titanium product has that this original data point did not is oxygen. So if you subtract that, you'll get just the mass of the oxygen. So that's going to be 1.55 grams of oxygen. And in this case, guys, it's not O2. Okay, it's just O because it's part of a compound. Now we're all set and we're ready to do our empirical formula problem. Okay, so we're just going to go from grams to moles. So I'm going to do that and then I'll come back to you. I've carried out the conversion from grams to moles for both the titanium and the oxygen using the molar mass. And now I'm ready to divide by my smallest answer. So easiest thing in the whole world is to figure out which is your smaller value. So the smaller value is the 0.0480. So obviously when you divide that, you're going to get a 1. And then we're also going to divide our moles of oxygen by that same value. Okay, when we do that on your calculator, we get approximately super close to the whole number 2. So what those are telling us are the mole ratios within the compound. So we have 1 titanium, we don't write a subscript of 1, and we have 2 oxygens. So TiO2 is the empirical formula. And then in part B, it says name the compound. Now, since this is a metal, okay, with a non-metal, we would not employ prefixes. Instead, we would say titanium. Because titanium has a variable charge, it's a transition metal, we have to show that charge in parentheses in Roman numerals, but let's name the anion. So the anion is oxide. Okay, so oxide has a -2 charge. There are 2 of them, so it's going to have a -4 charge. That means that there's going to be a +4 charge on the titanium, so we would write an IV for Roman numeral 4 for the name, titanium 4 oxide. And then lastly, we have letter C. Why was the titanium heated more than once? I already answered that. It's to heat to constant mass and be sure that all of the titanium was converted to the titanium oxide, or the titanium 4 oxide in this case. Here's some bonus content. This problem doesn't talk about molecular formula, but I still wanted to address it. If you would have been asked for the molecular formula, that means how the compound actually exists in nature. So it may not be the lowest whole number ratio, which is what empirical formula is. So in order to find that, you have to find this kind of whole number multiplier, which I'm just denoting as X. And in order to do that, you're going to take the molar mass of the compound, as it does exist in nature, divided by the molar mass of the empirical formula. Now this number in the numerator, that needs to be given to you in the problem. Okay, so if it's not, or if enough information isn't given to you, then you're not going to be able to solve for the molecular formula. And the empirical formula, oh, well, you just found that. So you can just add up the molar mass of that using the periodic table. So for example, if we were asked to find the molecular formula, I would have told you that the molar mass of the compound is approximately 80 grams per mole. I would have given you that information, and then you would have actually added up the molar mass of the titanium 4 oxide and recognized that it's 79.87 grams per mole. And you would have said, oh, okay, that's approximately equal to the whole number 1. This always has to come out to a whole number. It doesn't have to be 1, it could be 2, 3, 4, 5, 6, but has to be a whole number. So you can see in this case, the empirical and the molecular formulas are the same. If we would have had like 160 grams per mole here, this would have been a 2. And then we'd have to multiply through all of our subscripts. So we would have had Ti2O4. That's not the case for this problem. But that's a refresher on molecular formula.